So the next question asks us to find the point of intersection of two lines. And the two lines that were given have equations I'm going to put up on the screen in a minute. They're line A and line B. And the question asks us to find the point of intersection. So that point right here, which is common to both lines. And the equations that we get for these two lines are, respectively, so here are the equations of the two lines that we were given. The red line is y equals x plus 3. The blue line has equation 2x plus 3y equals 14. This, by the way, is the Desmos online graphing calculator tool. It's linked through our Blackboard site. It kind of does most everything that a graphing calculator does, but more and better and free and online. It also has a nice mobile app, so I use it on my iPad and on my iPhone on occasion. So what I've done is I've just put both of those equations into Desmos to recreate the graph that's given to us in this problem. And so our job is to find the coordinates of this intersection point. The great thing about Desmos is if I just click on that point, it's going to tell me what the coordinates are. So now we know what we expect the solution to this equation to be, 1, 4. So this just gives us a visual. But of course, graphs are something we can never take at face value as far as their accuracy. Right? We don't know if we're just drawing our own graph, whether this might be 1, 4, or whether it's maybe 0.9, 3.2, or something else that's not quite 1, 4. So let's go ahead and do the algebra that would be necessary to find this intersection point to make sure that 1, 4 is indeed the intersection that we're looking for. So I have here a system of two equations in two unknowns, x and y, and I want to find a solution. I want to determine what x and y balance both of these equations. We learned sort of two different methods for doing this, and ultimately at the end of the day, I don't care which version that you decide to use. Use the one that works best for you, the one that you have the most success with, the one that you'll remember better. That being said, I know which version I would choose for this particular problem. Would you prefer to approach this with a substitution method or an elimination method? What do you think?
Substitution.
Substitution, I agree. Why is substitution a sort of a quicker choice for this particular system of two equations?
Because you have a y already.
Yeah, the first equation already has y by itself. It's already been solved. Y is explicitly equal to x plus 3. And so it'll be easier for us to use substitution because immediately we can take this expression, which now we know defines y, x plus 3, and just plug it into the second equation and achieve the substitution step. Most systems of equations that we encounter aren't set up so nicely for substitution. So when we do get one that's set up that nicely, let's make use of it. So what that looks like again is I'm just going to take this x plus 3, which defines y, according to the first equation, and just substitute it in place of the y in the second equation. What that does is it gets rid of the y in the second equation and gives us something we can solve for x. So 2x plus 3y, but now in place of y, I have x plus 3 is equal to 14. And so now we get a little quick review of how to solve equations. My first step is to simplify everything that's on each side of the equation, and that entails getting rid of all the parentheses wherever we can. So what are my options for how to get rid of the parentheses around the quantity x plus 3? So yeah, we're just going to need to multiply this 3 across into the x and across into the 3, distributing multiplication across addition. So that's going to give me a 3x plus 3 times 3. That's 9. And the rest of my equation remains the same for the moment. 2x plus this equals 14. And then how do I finish making this left-hand side simpler? 2 plus 3, combining the like terms, 2x and 3x. We're going to talk more about like terms later on today because they play an especially increased role when you start talking about exponents. So 5x plus 9 is equal to 14. And now we've done all the simplifying that we can do. Now all we need to do is reverse the order of operations. So deal with all the addition and subtraction that we can first to strip that away from our x, and then strip any multiplication or division away from x. So what addition and subtraction can I do to get the x to be a little bit more lonely? Minus 9 on both sides. Perfect. 14 minus 9 on the right-hand side is going to give me 5. On the left-hand side, I have 5 times x. So then what's my last step to get that x alone?
14 minus 9.
That I just did. Yeah, I need to get rid of this 5 somehow, which I can do by dividing by 5. on both sides. And so what that's going to give me is a value for x. X equals 1. That's 5 divided by 5. So that's great. That means we have our first of our two values in our ordered pair. One of the things I noticed some people doing on quizzes is that they would stop right here and say, all right, I got my x, I'm done. When in fact, a solution to a system of equations needs to include not only an x, but also its corresponding y. So how do I turn this x into a y to finish my solution? How do I find out what y is as a result of x being 1?
You have to plug the x
Yeah,
into the other equation.
plug the x back into, here's the good news, I can plug it back into whichever equation I feel like. I could either plug it into the second equation, or I could plug it into the first equation. Doesn't matter, both of them should tell me the same story if this y is really going to solve both equations. In other words, if my x is correct, then it doesn't matter which of the two equations I plug into to find the y. So, in this case, I'm probably going to pick the easier of the two to work with, right? Rather than picking 2x plus 3y equals 14, let me pick y equals x plus 3. That seems like a much easier equation to work with. So I'll plug in a 1 for x into the first equation, which was y equals x plus 3. And then I find y is equal to 4, which comports with the graph that we had Desmos generate for us here. So substitution is a great technique for solving a system, and it's not always the most obvious one to use, but when one of our variables is already solved for, it's probably the quickest choice. We can always use substitution if you want to go through the trouble of solving one of the equations for y or for x first. That's always an option. But whichever method you use, the x and the y that you obtain need to be solutions to both equations at the same time.